Okay, so there are basically two methods for finding the slope of a line. The first one is using the rise over the run method, so let's have a look at that. And what we do here is we just can select any 2 points on the line. So in this case we've got our 2 points there, and we'll call them x1 and y1 and x2 and y2, and we just are going to calculate the vertical difference between the points and the horizontal difference. So what we mean by that is that the vertical rise between those points divided by the horizontal run will be the slope, or the gradient m. So let's have a look how we do that. So the vertical rise, to start with, is this height here. It's the height difference between the 2 points, and we can calculate that by subtracting the y-coordinate of one point from the other, and that will give us the height difference there. And in the same way, the horizontal run is calculated by subtracting the x-coordinate of one point from the other, and we get that horizontal distance there. Now the slope, or the gradient, is just the vertical rise over the horizontal run, which means that it's y2 subtract y1 over x2 subtract x1, and that becomes the formula that we can use to calculate the gradient. And so in this case, if we display the values of these 2 points, which turn out to be 7, 6 and 3, 2, then we can calculate the gradient in this case. So the rise is 6 minus 2 and the run is 7 minus 3, which means that the gradient is 4 divided by 4, as we can see there, and of course that's equal to 1. So in this case the gradient is 1. So if we have a look at the second method of calculating the gradient, that's using the angle that the line is making with the x-axis. So the way that this works is we can begin by thinking about it in the same sort of way as the rise over the run that we were looking at before, except because it's a right angle triangle, then we could think of those terms as the opposite over the adjacent. And if we think back to our definition of trigonometry, angles and so on, then the tan of theta is opposite over adjacent. So the tan of that angle is the opposite over the adjacent, which means that m is equal to tan theta, as we can write there. And if that's the case, we can just calculate the tan of the particular angle we've got. So in this case it's tan of 45, and the tan of 45 is 1. So that's given us the same answer as the other method, which of course makes sense because it's the same line. It should be the same solution. And then finally we'll just proceed to the last step here, and we will change the line. So I'm just going to drag this back so it's a steeper gradient. And then if we were to backtrack through that explanation a bit, we can come back to this stage where we were calculating the tan of the angle as the rise over the run, the opposite over the adjacent, tan of the angle. The tan of 63.43, it turns out to be 2. So we've got a line here that's twice as steep now as the previous line. And if we went back to the first method and calculated the difference between the coordinates here, so we can calculate the rise as the y2 minus y1 over x2 minus x1, and now in this case it gives us the values of 6 minus 2 over 3 minus 1, which turns out to be 4 divided by 2, and that 4 divided by 2 is of course equal to 2. So we can see that of course it's given us the same solution as the tan method again. And again it means that this vertical rise is twice the horizontal run for any pair of points that you choose on the line. So if we had chosen our points to be up here, say, then it would turn out still that this distance here is twice this distance as well. And if we work through the calculations, we still get the slope of 2. In deciding between these methods, it really depends on whether that you know the angle or if you know a couple of points on the line. So if you knew 2 points on the line, it would be easier to use the other method. If you just knew the angle, it's easier to use this method.